Good morning, everyone. My name is Hakchun Kiachran, and today I'm going to present about machine learning and its interaction with databases and data management. I hope this presentation will give you a better understanding of machine learning and how it builds a strong connection with the field of data. So let's move in the introduction and background part. Okay, machine learning is growing rapidly in computer science. It provides the ability to process large datasets, analyze patterns, and make accurate predictions. At the same time, data itself has developed strongly, creating a close relationship between machine learning and database or data management. On one hand, machine learning helps speed up queries, ensure data quality, detect anomalies, and make predictions. On the other hand, databases provide the large datasets needed to train and test models. This creates a mutually dependent relationship. Let's briefly review how machine learning evolved. In 1950, Alan Turing introduced the famous Turing test in his paper Computing Machinery and Intelligence, raising the question, can machine think? This laid the foundation for AI. Only a few years later, in 1959, Arthur Samwell at IBM introduced the term machine learning and developed a checkers playing program that could improve its performance after each game. An early example of learning from data. In the 1960s, Joseph Weizenbaum created ELIZA, one of the first chatbots which showed the potential of machines to process language. By the 1990s, machine learning separated from AI and focused more on probability and statistics, using methods such as decision trees and support vector machines (SVM). However, progress at this stage was limited by the availability of and size of data. The 2000s marked a turning point with the growth of the Internet and the arrival of big data. Machine learning models could finally train on massive datasets, leading to better accuracy, but with big data also came challenges in data management, highlighting the need for effective systems to handle this world. Okay, let's talk about the relationship between machine learning and database data management. Machine learning requires large, high-quality datasets. Good data management ensures that these datasets are accurate, consistent, and reliable. It allows models to train more effectively while saving time and resources. It also helps detect anomalies, duplicates, or missing values, reducing risk in model training. In return, machine learning also improves databases. Machine learning algorithms can predict storage needs, optimize performance, retrieve data faster, and even improve security by spotting unusual patterns. For data management, machine learning can clean redundant values, classify data, and maintain overall quality. In short, machine learning and database support each other's growth. I will talk about the machine learning workflow. Now let's look at how machine learning actually works through its workflow. The first stage is data collection and pre-processing. Data comes from sources such as databases, APIs, or the web, but raw data is often messy. Pre-processing includes cleaning, normalization, and preparing the data so that it is consistent and ready for training. The second stage is model selection and training. Trainers choose candidate models depending on the task and data type. For example, linear models, tree-based models, or neural networks. These models are trained on part of the dataset, while another part is reserved for testing. Evaluation metrics are also used to find the best performing model. The third stage is testing and tuning. Here, the model is tested on unseen data to check its accuracy. Hyperparameters are adjusted to optimize performance. This stage ensures the model is reliable in real-world situations. The final stage is deployment and monitoring. After training, models are deployed as APIs or on cloud platforms like Google Cloud or Azure. Monitoring is essential to detect performance drops, data drift, and retrain the model when necessary. This workflow shows that machine learning is not a one-time process, but continuous improvement. So let's move on the benefits and opportunities of machine learning. Okay, machine learning offers many benefits. For databases, machine learning can speed up queries, improves efficiency, and enhance security by detecting anomalies. For data management, machine learning ensures higher quality by automatically cleaning and classifying data. From a business perspective, machine learning allows faster and more accurate decision making. It helps analyze customer behavior, identify market trends, and reduce risks. This lets organizations optimize operations and focus human resources on creative work instead of repetitive tasks. Despite its strengths, machine learning also has some drawbacks. Firstly, it is highly dependent on data. Poor quality data leads to poor results. Secondly, privacy concerns arise when machine learning uses sensitive data, such as in healthcare or military. Another limitation is the high deployment cost. Building and maintaining machine learning models requires expertise, large datasets, and powerful computing infrastructure. Finally, machine learning models are not always correct. They can give biased or inaccurate predictions if algorithms are poorly designed or training is limited. In conclusion, machine learning is one of the most important technologies in computer science today. By following a clear workflow from data preparation to deployment and monitoring, machine learning provides powerful applications for databases and data management. It improves efficiency, security, and accuracy, while opening opportunities for innovation. However, its effectiveness depends on data quality, good management, and careful attention to cost and risk. Thank you very much for listening.